The world witnessed endless technologies, especially when it comes to artificial intelligence, drones, self-driving cars, and whatnot. Well, now is the time to see the ultimate development that involves human life. Yeah, you heard it right. Today we'll look at robots starting to take over surgery. Hey guys, welcome back to Robot Future, but before we move on, don't forget to drop a like. If you're new here, don't hesitate to smash that subscribe button. Also, do click on the bell icon to turn on our post notifications. So without further delay, let's get started. Across the world in hospitals, surgeons are to be sharing their jobs with robots. Robotic surgery. By automating specific stages of surgery, the goal is not to eliminate doctors from the operating room, but to relieve their workload and possibly even enhance success rates where there is the opportunity for improvement. Robots can already outperform humans in some surgical operations, such as inserting a pin into a bone. The goal is that autonomous robots will improve the accuracy of other procedures, including incisions and suturing, while reducing the hazards associated with overworked surgeons. Surgical robots have cameras that record three-dimensional videos of each procedure. The video is fed into a viewfinder that surgeons use to guide the procedure while viewing it via the robot's eyes. However, these photos also serve as a detailed roadmap of how surgeries are carried out subsequently. They can assist new surgeons in learning how to use these robots and train robots to perform tasks on their own. A neural network may retain the same skills by evaluating photos illustrating how a surgeon leads the robot. The two most advanced and promising initiatives integrating robotics and eye surgery are led by Kopatanovic, a clinician scientist at the University of Oxford, and Hubschman, associate professor of ophthalmology and director of UCLA's Advanced Robotic Eye Surgery Laboratory. Mark DeSmit, retina specialist, co-founder, and chief medical officer of Preceyes BV, developed the Preceyes surgical system. He sought engineering help from the Netherlands 15 years ago to create a micro-robot prototype for vitreoretinal surgery. In 2019, the CE mark was awarded to the Preceyes surgical system, successfully verified through preclinical and clinical trials. The intraocular robotic interventional surgical system, IRIS, developed by UCLA's Mechatronics and Controls Laboratory and the Stein Eye Institute, is the second project. For more than a decade, Hubschman and Su-Chin Shao, PhD, professor of mechanical and aeronautical engineering at UCLA, have worked together on this project. The Preceyes surgical system is a telemanipulation system with a master and slave. A surgeon's joystick is attached to a robotic arm that holds the tools and conducts the surgical motions within the eye through a remote connection. The surgeon directs the motion of the instruments using the surgical microscope. Like a manually controlled instrument, the system allows for a high degree of precision and 2 rotations around the entry point. It can also open and close equipment inside the eye and activate a light source or a laser, according to DeSmet. A computer controls the pace at which instruments move through the eye, so motions can be faster while devices are far away from fragile structures and gradually slow down to almost no motion as they reach the retinal surface. It also creates a recollection of where surgeons were at each time, allowing them to stop and continue moving from the same spot. It can be configured to set virtual boundaries to keep the arm from traveling too far or to progress in predetermined steps, such as 50 or 10 meters, to reach a certain point. The University of Oxford conducted the first clinical trial with the Preceyes surgical technique. The trial began with 12 randomly randomized patients to either robot-assisted surgery or regular manual surgery for epiretinal membrane or internal limiting membrane excision. Thomas L. Edwards, one of the surgeons who performed the robotic-assisted procedures, describes it as an amazing experience of close collaboration between the clinical team led by Professor Robert McLaren and the systems engineers. It was thrilling to have a robot in the operating room with Preceyes engineers. The precision and superhuman abilities of the machine were unlike anything we'd ever seen. You'd never think that you'd be able to put the tip of a needle so close to the retina, then let go of the controller and see the needle stay stationary. It was tough to believe, to be honest, Edwards said. Edwards has returned to Australia where he's looking into using the Preceyes system in future joint research. Preceyes were utilized in the second stage of the study to inject a recombinant tissue plasminogen activator, a clotbuster agent, into the retinas of 12 patients who had vision loss owing to subretinal hemorrhage. In 2018, Kopatanovic was first exposed to the technology. I was taught how to utilize the robot and then performed my surgeries on people. I was fortunate. It was a once-in-a-lifetime opportunity for a select few, she explained. The trial went exceptionally well and it is now finished and set to be published. She has planned training sessions for OR staff to implement a specific protocol for robot-assisted surgery, and she continues to engage with prec guys to update the technology. When a new operation is introduced, not only the surgeons must be trained, but the entire staff must know how to set up the equipment and which parts must be sanitized, clothed, and draped, Kapetanovic explained. A human hand could not compete with the robot in the operation of subretinal injections. Surgeons' physiological tremor is approximately 100 meters, ranging from 80 to 250 meters, and it intensifies during static work. Prec Eyes allows you to accurately enter the subretinal space. The robot translates your hand movements into micro movements. When you reach the precise area in the retina you're going for, the needle is held very still, which allows executing the infusion gently and steadily. Hand tremor tends to expand the small hole in the retina when we execute the same process manually, and the drug then refluxes back into the vitreous, producing inflammation. That's why we normally want to inject and exit the eye as quickly as possible. Prec Eyes permits you to keep the needle stationary for longer periods of time, allowing you to do a gradual, controlled infusion in minutes, rather than seconds, while maintaining the retinotomy area's tightness. I conducted a lot of industrial-type research before getting involved in the IRIS project, such as metal cutting and material removal, so the concept of designing a robot to cut and remove the crystalline lens fascinated me, Sal said. The IRIS is designed to perform anterior and posterior intraocular surgical procedures. However, recent advancements have focused on cataract surgery, specifically on the stage of lens removal, with the rest of the treatment being handled by the femtosecond laser. Another task that will eventually be entrusted to the robot is the IOL implementation. Iris's two arms can simultaneously handle two surgical instruments through millimeter-wide ocular incisions, and each arm can autonomously switch between several surgical instruments. For preoperative planning and surgical guidance, the platform includes an OCT system. While the robot does all of the scanning and maneuvers fully automatedly, the surgeon can always intervene at precise points with a mouse click, assign a task, or change or override the operation. All three components of a fully autonomous robotic system are present in our robot: sensing, image guiding, and decision and control capabilities. In addition to visual indication, the robotic system can deliver tactile feedback, according to Hubschman. Enhanced feedback capabilities can be beneficial when doing specific surgical operations, such as delicate retinal procedures. When you play video games, you can sense vibration or resistance in the joystick. When the car runs off-road during the game, you may encounter some opposition. We can transfer important information into haptic feedback with robotic manipulators, he stated. Much of what may theoretically be perceived through the forceps is below the human threshold during manual surgery, and surgeons must rely only on visual cues. Both visual and tactile feedback is delivered and potentiated using iris, resulting in a level of precision and accuracy that humans cannot accomplish. The OCT will pinpoint the exact location of the lens fragments, allowing the robotic arm to softly and precisely fish those fragments out without risking capsule rupture. During standard cataract surgery, there's a trade-off between thoroughly cleaning the bag and risking capsule rupture against leaving some debris in the bag and risking posterior capsule opacification. We can clean the capsule fully and extremely safely thanks to the iris system's combination of flawless imaging and sensing capabilities, Hubschman stated. The human reaction time is roughly 300 milliseconds, whereas the system would respond in 20 to 30 milliseconds. Any eye movement is also detected and adjusted promptly by the robot. The connection with self-driving automobiles is a good one. According to data, nearly 97% of collisions are caused by human mistakes. Due to a more exact evaluation of the situation, greater control, and a faster reaction time than humans, the chance of an accident is dramatically reduced with an autonomous vehicle. In the same way that autonomous automobiles learn from each mile traveled, machine learning improves the system's performance during each surgery, making it more and more dependable. What do you guys think about robots taking over the surgery? Do comment below in the comment section. For the foreseeable future, automation will complement rather than replace surgeons. Even so, this may have a significant impact. Doctors might, for example, perform surgeries over distances significantly greater than the operating room's width from miles or more away, perhaps assisting wounded warriors on distant battlefields. The signal lag is now too severe to make that possible. Long-distance surgery could become feasible if a robot could do at least some of the procedures independently. Remote surgery at even greater distances would require the same technologies. That's all we've got for you today, guys. Also, don't forget to thumbs up the video and subscribe for more new content from the field of robotics, and we'll see you again soon.